Hello, thank you for watching. This video will be about building a small guitar tube amplifier. I've never built any type of tube amplifier. I just repair a couple of vintage old radios, but never had the experience of building a complete amplifier from scratch. So, but after watching many videos on YouTube, some channels like Uncle Dog, the Labs, and the guitarologist, I think it's pronounced. Those channels pushed me a little bit into trying to do this, or at least take a shot at it. My idea is to build a small single-ended tube amplifier based on the 6V6 output tube and a 12AX7 preamp, based maybe on the Fender Champ, one of the Fender Champ models. I don't know yet which one, and maybe it's not an exact copy. I will be designing it on the go. But basically it's a single-ended 6V6 amplifier with a 12AX7 preamp. I didn't go out and buy any tubes. I don't have many tubes. I have some tubes, but by chance I had to have a 6V6. I have only one, and I have the proper socket. It's and also a 12AX7 with its socket also. So I have all the tubes, no problem. And well, I had to send to manufacture the transformers. It's very difficult here to buy the transformers, although I could have bought the transformers online and got them shipped here down to Uruguay and then import them, and it's a big hassle. If this goes out okay, I may be doing that in the near future if I decide to build another type of amplifier. But as this is a test, I decided to go locally here and send to build the transformers under my specifications. So this is what I got. I got two transformers. This will be the power transformer. I could decide on the size. I decided to go preferably bigger than smaller. So I think this transformer is more than enough for the powering this amplifier. This is the power the power transformer of the tube amplifier, and we have here a 6V with I've asked for a center tab on the 6V for less hum, and this is the high voltage, and this is the line input voltage. So I hope this works. I will use solid state rectifiers. I will use a couple of diodes, or I think I'll use a bridge rectifier. I'll have to see on that, but I'm not planning on using a tube rectifier on this first go. So let's see. So this is the power amplifier, sorry, the power transformer, and for the output transformer I've asked to build this. As it's a 6V6 single-ended output tube. This is a 5K here for the 6V6, and this would be 4 and 8 ohm tabs for the output. So this would be the output transformer. No special lamination or anything for the audio, because this is just like the same material and the same techniques on the winding used for power transformers. This is what can be done locally, so I don't know, but something will come out of this, I have no doubt. Okay, so I was thinking on how to build the chassis, and I had some ideas, but that's what kept me a bit with doubt, because I said, well, maybe I build a chassis and then the whole amplifier will result as a Frankenstein thing. So you know, maybe it will be always there in a chassis with no cabinet, no nothing. So I went to a flea market, a very popular flea market here, which is on Sundays here in Montevideo, and looking around, I found this little solid state practice guitar amp, which is no name practice guitar, but it looks very well built for it being no name, right? It has a little speaker there. I don't even know what it is. I mean, I'm not educated in this, so maybe somebody looks at this and says, oh, it's such and such amplifier. I have no idea. So, but what interested me is that it has a really nice metal chassis here for the electronics. So I will take it out and use all the metal parts and the cabinet for the tube amplifier. And it also has the knobs are this chicken head type, and the power switch. It has everything, so it's a very nice for the price I paid on the flea market. So it wasn't extremely cheap, but I think overall that this will be cheaper as a solution using this practice amp than building something myself and never ending the project. So what I will do now is, following this, I will remove the chassis here and see what's inside, but basically strip everything out and use this metal part as the chassis for the tube amplifier itself. It has a very nice cord, everything. So I didn't even ask if it was in working condition. They told me yes, it works, you know. But in flea markets, they always tell you it works, and you never know. So I don't think I'm even going to plug it in. I think I will tear it apart. So let's see. After some progress, I will show you what's okay. This is the little practice amp, and this is the speaker. It's quite a small speaker. I don't know how many inches, but maybe 5 inches. I don't know. And I may, as there is quite some space here, I may replace this with a bigger speaker sometime. So that's why I'm trying to leave as much room as possible. The speaker goes here in this fashion here, so that's why I'm not putting, for example, the output tube here or the transformer here. I'm trying to leave this space as clear as possible for having the possibility of putting a bigger speaker in the amp. Okay, that's the progress from now. I think I will rivet these transformers in place. I like using pop rivets in the transformers. They fit very strongly, and then with the vibration and everything don't move. And then I have to make the holes for the sockets, clean the sockets and everything, and then once I have all this hardware mounted, I can start working on the underside for the circuit itself. I've placed both transformers as planned. I use these pop rivets, very sturdy ones, so the transformers are really very well held to the chassis. I've used some tubing to protect the different wires going into the chassis through the holes, and then I also installed the sockets for the tubes. As you can see, I built the power supply, which is composed of a, let's see if this focuses, let me see. Okay, it's composed of a full wave bridge rectifier. As the output winding of the power transformer has no center tap, I had to use a bridge rectifier. In fact, this was by design, because as you know, the transformers were custom made, but this was by design. So this was decided from the start. And here I have the first drop resistor and two capacitors. This would be the ground point, and I will make a start point close to the, sorry for the shakiness, but I will make a start point close to the input jack. So this would be the input jack, and I will make a start point in the chassis very close to here. So I will send this ground cable to that ground point, and I will connect all the grounds, or as much grounds as I can, to that start point, so to minimize ground loop problems, if any. So let's see how that works out. For example, I've been looking for around for switched, as they call it, switch input plugs, not the plug, the jack, mono ones, like for the guitars, and they are very difficult to find. I don't know why. So the ones I got are not the ones I would like to put there, but for a start, if not, I won't build the amplifier anytime soon. So I'll put those I've managed to get, and then I will do all the input circuitry towards the first stage of the 12AX7, and I'll follow along. So as an overview, this is the lines input side of the power transformer, and here is the output. This is the filament with a center tab. That was by design too. I designed the transformer so that it has a center tab on the filament voltage, and then I have the power supply for the plus B, with this is the ground, and you have the two different outputs, one here and one there, and this will go here. And this is the output transformer. This would be the high impedance part, and this is the output part with 4 and 8 ohm tabs. And that's it for the moment. Okay, progress so far. As you can see, I've put all the wiring for the filaments on both tubes here in parallel, and I installed a terminal strip here with the center, as you can see here, the center connection is soldered to ground directly to the chassis. I've used, I don't have the super Unger majestic soldering iron as Terry from D-Labs have, but I have a big one here also, which helped me a lot in soldering the terminal strip to ground.
So that's a really nice ground connection, and I will use it for as a ground start point here. So I will solder there. It's not soldered yet because I will add some other wiring there. To that point that it's soldered to chassis will go the ground from the power supply section, and the center tab of the filament winding of the power transformer, and of course the ground of this the negative lead of this electrolytic cap, which if I use the schematic here, we have, let's see if this focus, there we go. We have this section here is over here, it's over here, and then this red wire connects up to here, and I have in that terminal strip I have this section here, which is this electrolytic cap and this drop down resistor, and from here there goes the two 100k ohm resistors, this one and this one, that go to the two plates of the two sections, the plates of the two sections of the 12AX7. So as you can see here, I have the red wire coming in from the power supply, the drop down resistor, and the capacitor to ground, to the chassis ground. And from this point we have the two 100k resistor, one that goes to pin 1, which is one plate, and the other one will go to pin 6, which is not soldered, but because there will be this coupling to the next section of the amplifier will go here, so I haven't soldered it yet. So that's the progress so far. As you can see, I've managed to build and assemble all the components around the 12AX7 preamp tube. It was quite a lot of work, most considering that when I was finishing the wiring up, one of the leads of the socket broke, so I had to replace the whole socket. But that improved the layout a little bit, because I was finding a lot of trouble to place the parts, and then when I replaced the socket, I replaced it in a different, I located in a different orientation, which helped me a lot in the placement of the parts. Moreover, I put a standoff here with a ground point, which comes from, with this green wire, comes from the star ground here, which helped me with several ground connections locally. So to highlight, I also did the tone stack here. This would be the volume pot there. Let's see if this focus. Okay, this would be the volume pot, and this would be bass and treble. I'm trying to make a fusion between the Princeton schematic that has, it's very simple, it has a volume knob and nothing else, with the vibrochamp, but I will not incorporate the vibrato, but I would like to put the tone stack. So what I did is insert in between the input, the first triode and the second triode, I inserted the tone stack. So this is, and it's an experiment. Let's see what happens. I'll build the circuit exactly the same as the Princeton, but inserting the tone stack as in the vibrochamp. And this is what can be seen here. That's the tone stack. As you can see here, these are the input jacks. This is the star ground point. and from here are the two 100k resistors that go to the plate of the two triodes, and well, everything is wired there. I think I haven't made any mistake. And then I try to use a lot of shielded cable between the tube itself and the different parts that were far away, only shielding, only connecting the ground on one of the ends of the wire so as not to create grounding loops. And this little cable, shielded cable you see here, will go to the output tube via the coupling capacitor that will be very close here to the output tube. It's also shielded, and the shield is grounded on this side but won't be grounded on this one. So let's see what will happen. This hole here is for another VR that will go there, another knob that will be a variable feedback. I will put a variable resistor here. In fact, it will be a fixed resistor with a variable resistor in series, so that I can modify the feedback so as to change the breakdown maybe of the amplifier. Let's see. This idea I got it from Uncle Dog video. So as I had the little hole here in the chassis from this is this is a used chassis. I decided to add a VR to put a variable feedback, just to see what's the result. Okay, I think this is getting ready to test. I assembled all the output stage, the components of the output stage here. This is the coupling capacitor, this is the cathode resistor, and its bypass capacitor. The signal comes from the preamplifier stage to this point here, and well, I think everything is correctly wired there. So that's the output stage, the 6v6 tube there, and this is the 12AX7. I have added another VR here with a 10k resistors in series, and this is just connected this way in order to test it. And after testing the amplifier, and if everything works well, that will be fixed properly. This is the output of the output transformer. This would be the ground connection, and this would be the 8 ohm output, and this would be the 4 ohm output of the transformer, and this would be the feedback loop here to the preamplifier. As mentioned before, this VR, I've added this VR in order to dynamically change the feedback of the amplifier. In order to wire correctly the feedback, I had to previously check the proper phase of the output relative to the input of the transformer. So I had to inject in the primary of the transformer, or in fact I did it the other way around. I injected a signal, a 1 kilohertz signal in the secondary of the transformer, and I verified that the output of the transformer was in phase. So I selected the correct wires so as them to be in phase, because as you can see here, the feedback for it to work properly must be in phase with the input of the transformer. So I'm getting ready to test this thing, so I'm a bit not worried but a bit anxious of what's going to happen. I'm back, and now I powered on the amplifier. First of all, I'll show you this, my friend, the little guy getting electrocuted, because this is not funny. All voltages here are lethal, and you have to know what you're doing before attempting to do this yourself. So take care. It's a warning, but it's one of those warnings that are never too many times said. So it's important. So leaving this aside, over there, what I've done is I've put the two tubes, the 6v6 and the 12AX7 over there, and connected the speaker from the cabinet of the El Cheapo practice amp I bought at the flea market, as you all know. And at this time the unit is powered on, as you can see, and I will put the microphone very close to the speaker. First of all, I'll show you it's on. I'll touch here with my finger to introduce a noise in the input. Be careful, it should be in the input, not in our high voltage plate. You see, the amplifier is working. I have no instrument here to test it, but let's see the volume or the noise it's making. Okay, that's the noise. I measured the bias here on the output 6v6 tube, and this is the cathode resistor, this one. I started with a 470 ohm resistor, as it's normal in the schematic, but I had to increase it up to an 820. It's up, and really it's a 804 ohm resistor, so as to reach not more than 32 milliamp. At the beginning it was biased at about 48 milliamps, which is in my opinion far too much. I checked the data sheet on the handbook, which is somewhere there, and it says that the bias current should be about 30 something milliamps. So I corrected that. I don't know exactly why, but that's it. I will leave it like that for the moment. Okay, so now what I'll have to do is I think I will take it somewhere I have a guitar to listen to it, and then continue with the tidying up of all these wires, and put the power input power protections and the fuse, for example, and the power switch and everything, so as to, and a speaker connector, and then I think it'll be finished. And this is the top view of the little single-ended guitar amplifier as designed. There's some space here for maybe a bigger speaker in the cabinet. 12AX7, which is up and running, as you can see there. It's a maybe oh, I think it's yes, I think it's gone. No, it's a Telefunken. It's an old stock Telefunken. Let me see if it can be seen over there. I don't know if this focuses there. Yeah, it's an old stock Telefunken, and that's the 6v6 also up and running. So very happy for now. Focus there. I did a very simple test of the amplifier with a guitar. I don't know how to play guitar, so it's not like it's me playing the guitar. I've just connected the amplifier to the speaker of the Marshall combo amp you see on the back. That Marshall amplifier, it's a solid state one, but I think it's a really very decent one. I remember for the price, both the guitar and the amplifier belong to my brother. They are like a 15 or 20-year-old set. The guitar is a Squier by Fender, and both the amp and the guitar have very low mileage on them. I don't know how to play, but I have the guitar and the amplifier to test. I disconnected the speaker from on the Marshall amplifier, disconnected the speaker from the amplifier itself, and connected the speaker to the output of my tube amplifier. And as you can see, I connected the guitar to the amplifier. Following, at the end of this video, you will hear the noises produced by the guitar, because by no means it could be considered as music. It's just me making some noises with the guitar. But at least you can see that the amplifier is working. I also measure some voltages again on the amplifier, and I think, I don't know, I never experienced, I don't have no experience with these amplifiers. The Marshall amplifier, it clearly has more power. It's a more powerful amplifier, but I don't know what should be the performance of a single-ended 6v6 based amplifier. So what I will do next, but this would be in a separate video, is that I will measure the performance a bit with the oscilloscope of each section of the amplifier. Maybe see when each section reaches distortion and how much power can be achieved with the amplifier. Maybe to improve a bit the performance, if that's possible, or if it's required. I don't know. The tone stack, I'm not sure if it's working correctly. It makes some differences, but not very effective, I think it is. I don't know. And the variable feedback, that works really nice, because when the feedback is in its lowest position, the amplifier tends to distort in a really nice way, so makes a really nice a bit distorted tone, which can be nice for some type of music. So that's variable and can be used as you wish. Both inputs have different gain, as expected from the design, and that's working fine. And a good what's good on the amplifier is that, as you saw before, they have no issues with hum whatsoever, and no issues with the noise floor of the amplifier itself is really low, extremely low. So I'm very happy with that. Maybe the topology I adopted for the grounding helped a lot. So I'm very happy with that. Also, I'm very happy that on the first go everything worked fine. So I'm very pleased with that. And I don't know, maybe there will be a next video. I will try to. Oh yes, I've tested the amplifier in the Marshall speaker, because the little speaker from the cheap practice amp is really useless. It's really useless. So what I'll try to do also is try to get a better speaker for that small cabinet, and then I will assemble everything in the small cabinet, but with a better speaker. Okay, so I think this wraps it up, and I will end the video here. I hope you've enjoyed this video and it's helpful in some way or another. And also I have to thank many YouTubers like already mentioned Terry from D-Lab, Uncle Doug, Mr. Carson's Lab. Paul is a really good inspiration, and also inspiration, but his techniques are really good and inspiring. And I don't know, many others that I watch online, and sorry for not mentioning them, but you know it's difficult to have a list, but it's because of those people that I'll be able to learn and to make some of the things I do. Okay, best wishes for this 2019 that is just starting, and best luck to all. Till the next video, bye bye.